This lesson is on comparing linear regression functions or comparing linear equations. They both mean the same thing. Mostly we're comparing two different representations of y equals mx plus b. Okay? We're going to be either comparing that slope or that y-intercept. Number one, Brandy compared the slope of the function graphed below to the slope of the function. So here's this equation, and then we have this graph, and we're looking at slope. Which one is smaller? Well, let's first look at this graph. The slope I'm going to find by looking at rise over run. And now I'm going to need to find two perfect points. Now I'm sure that there's some in between there, but I see that this is a perfect point, as is this, on that x and that y axis. So I'm going to rise up 1, 2, 3, 4. So for the graph, the slope is 4 over 1, 2, 3, 4, 5, 6. I went up and to the right so that they're both positive, and that's an uphill line, and 4 over 6 reduces to 2/3. Now I'm looking at the slope of the equation. I cannot see the slope in that equation because that's written in standard form. So I'm going to get rid of that 5x, 10y. I cannot combine these two together as negative 5x plus 20, or 20 minus 5x. Either way, as long as you're not combining. Okay, y equals, this is negative 5 over 10. 10 doesn't go into 5. It just reduces to negative 1/2 x plus 2. And again, what I'm looking for is that slope, which is this number right here. And which one is smaller? Well, we're comparing 2/3 to negative 1/2. Negative 1/2 is smaller. So which function had the smaller slope? The answer is the equation. What is the difference when the slope of this equation is subtracted from the slope of this equation? First things first, I need to identify that the slope of this one is 7. That's in y equals mx plus b, slope-intercept form. And the next thing I need to identify is the slope here, except for I can't see it. It's in standard form, so fix it. And divide. Oh, that's a 3. Y equals negative 2x minus 4. Okay, and then we have to read what it says again. What is the difference? That means we're going to subtract the slope when this slope when it's subtracted from. So this is the from. This comes first, and I'm subtracting 7 from it. Negative 2 minus 7 more is negative 9. That's the difference between the slopes. A cell phone charge company A charges $15 startup fee plus 10 cents per minute. Okay, so company A, let's write that equation. It's 10 cents per minute. That's my slope plus the $15. And cell phone company B charges 25 cents per minute with no startup fee. Which function represents the difference between company A and B? Difference again, oh here it is, means to subtract. So I'm actually just going to subtract these two equations. I'm going to put D for difference. You could just also put Y equals. All that stuff means Y equals. 10 minus 25, 10 cents minus 25 cents is a negative 15 cents x. 15 minus, there's no startup fee here. 15 minus 0 is 15. That's the difference between the functions. We just subtracted straight down. Okay. 4, the table below shows the distance a person's biked. What's the meaning of the slope for the linear model? So this goes back to interpreting that slope. You could put this into L1 and L2 in your calculator. Or we also know that we could look at the change in y over the change in x. So obviously minutes is x and time traveled is y. My y is going up 4. Okay, my x is going up 3. So that's just a 4/3 is my slope. And I need to interpret it. So it's saying that they travel 4/3, or actually, and if we're thinking about distance, it makes more sense that this is 1 1/3 miles. So it's whatever it's happening for the y. So it's 1 1/3 miles every minute. 1 1/3. There. So I guess it looks like they're biking 1 1/3 miles every minute. That's the meaning of the slope. Miss Miller and Miss Hedgepath begin saving money on the same week. That shows the table shows that model of the representation for the money that they've saved. After how many weeks are they going to have this same amount of money? You could set up a table and start plugging in number of weeks, or we can set them equal to each other. 20x plus 5. Sorry about that. 20x plus 5, I want to know when it's going to be equal to 15.5x plus 7. I'm going to bring that 15.5 over, so 20 minus 15.5x. That'll get rid of this side, and then I'm going to get rid of this 5, subtract it here, so that's gone there. Subtract, we're left with 4.5x equals 7 minus 5 is 2. Divide by 4.5. Okay, so x equals, it's like 0.4 repeating, or 4/9. So not even after a whole week are they going to have that same amount of money. All right, what is the difference in the slopes of the following graphs? Okay, so this, I know that this is hard to see, but that's those points are also written for you. It's -2, 0, if you can't see it, and this is 0, 4. Okay, I'm going to rise over run. I'm going from 0 up to 4, so that's going up 4. And then I'm going from -2 over to 0, so that's going right 2. So the slope is 4 over 2, which is 2. That's the slope here. And then for this graph, I'm going to rise up 1, 2. That's up 2, and to the right, 1, which is also 2. But difference tells us to subtract, so 2 minus 2 obviously is 0. There is 0 difference in the slopes. And 7. 2 ramps are built to allow access to an entrance. Ramp 1 begins 10 feet from the door, which is 6 feet above the ground. Okay, ramp 2 begins with 12 feet from the same door. What's the relationship between the slopes? Okay, well, we know that we're talking about rise over run. So ramp 1, it's 10 feet from the door. That's your run. This is 6 feet above the ground. That's 6 over your 10. Okay, because that's the height over the across, which we can reduce to 3/5. Okay, so that's ramp 1, and then ramp 2, it begins with 12 feet from the same door, but what's the relationship between the slopes? I don't know the height here. So I don't know how that rise, how tall that ramp is. So this cannot be determined just because I don't have that number right there.